Hi and welcome to video 3, Unit 4, Topic 1, Integration. Applications of integration is this series of videos. And we're looking at using integration to find areas. And this is the third and final video to do with using technology in this series on finding areas. So I've just cut and pasted from the Casio textbook some ideas. So I've just cut and pasted from the Cambridge textbook some ideas how to use the Casio calculator. And I'm going to show you two ways now through two examples, and this video shouldn't take too long for that reason. So let's have a look at example 5 and just remind you that you can use the integration function in your run matrix screen to find the area as required. So here's my calculator. If I exit out of here, I will go to my menu, sorry. If I press 1, that takes me into the run matrix screen, and within there, if I click on, I'll just exit out to the main bit, if I click on option, you'll see that I have in calculate an integral sign. Not only that, but if I exit back out and just click on math, that's a shortcut for some common ones. Click F6 to move across, and there's integrate again. So I integrate, and the function that I want to integrate, just to remind myself, log base 2 of x square root between 1 and 16. So you'll see log base 2 does not exist as a function on my keypad, but if I'm looking for log base 2, I can go into my option, calculate, and shift along, and there's my log base 2, or log base a of b. So I want to do the square root of log, and then within here I can do base 2 of x, and I'd like to do this square root between 1 and 16 as my integral. And now I've filled in all the boxes, I press enter, and it will calculate an answer for me of 24.66. And so just for clarity, example 6 is similar. It's a repeat of example 3. Determine the exact area bounded by two functions. I'm going to show you how you can use the intersection points within the calculator, in the graph mode, to find an integral really quickly. So if I go back to my calculator, menu, graph, which is item 5. Now I've already plotted these two, or typed these two in as y6 and y7, so I'm going to use that. If I draw those two functions, there they are there. And now, if I go to gsolve, I can find the intersection points, but I don't actually want that. I don't really care what they are. What I actually want is the integral. So I go along gsolve integral, and I want the integral between two intersection points. Note, I can also find the integral between two roots, a mixture of special key points, and this will take the integral of a selected section, but I want the intersection points. So F3. That's my first intersection point, execute, move along. That's my second intersection point, execute. It colours it in, it tells me my upper and lower bound, and it tells me the integral is 0.218954141. This is the area, this is the integral. So if there is double section, it will give you the definite integral and the area as two separate items. And so now across the three videos, you should have enough knowledge to cover 12A, 12B and 12C. All the best.